All right, we're three past the hour. I'm gonna get started. So, hello everybody. My name is Edward Louie. Welcome to another Green Energy Series webinar. Today, we're going to be talking about the right way to weatherize your home, and I hope this is going to be a very full presentation. I've got like 45 slides, but they're mostly photos, so I hope that we'll be able to get through them within the hour. So this webinar is hosted through Solar Oregon. So for those who are new to and not sure about what Solar Oregon is, so Solar Oregon is a nonprofit that was founded in 1979. It puts us about 46 years old, and it grew from grassroots efforts to support clean and renewable energy. And we continue this mission today by continuing to be a bold voice and trusted educational resource to empower all individuals in the community, focusing mostly on Oregon to adopt solar energy. We offer many webinars and events throughout the year, including many offerings of a solar plus storage webinar. And we also provide that slide deck in person throughout the state as well. And this is sort of a 101 slide deck that helps new people who are unfamiliar with how to navigate the process of getting solar. Um, and this is kind of a 101 slide deck to help them get started in that process. We also do many solar tours throughout the year, particular tours in homes as well as tours of farms that have adopted solar. So in Oregon, a number of farms have adopted solar because what they've discovered is that this combination of solar panels, particularly panels that are semi-transparent, provides shade to their crops and resulting in significantly reduced water usage in the summertime, but yet there's still enough sunlight for the crops to grow well. And so the additional revenue and utility bill savings from the solar really helps the farm stay very profitable. Um, so we get to tour new sites each year, farms that have installed solar, and then we also do tours of homes that have installed solar, and particularly since quite a few homes have installed solar now, where those home tours we're focusing on homes that have um, gone through an electrification and net zero energy journey. Um, so homes that are a little bit further along than just getting solar, and that you get to tour those homes and hear from the homeowners about the steps and the journey of that process, because it really is a journey. It's typically, not something that people do in 1 year. It's a multi-year, sometimes even over 10-year effort to, get a home from very energy inefficient to very energy efficient, replacing gas appliances with electric appliances, and be able to utilize more and more of that great free energy from the sun. Um, we also do solarized campaigns throughout the year, and these are campaigns where we get like whole neighborhoods to get solar quotes all at once. And these quotes are special pricing for if the solar is installed at the same time as neighboring properties. And so then the solar contractor is able to buy panels in bulk and inverters in bulk, and then pass on those savings to customers. And then we also do peer-to-peer education events like this Green Energy series, where we deep dive into specific topics, such as this topic of how to weatherize your home in the most efficient and cost-effective and effective process. If you like to support our work, you can look us up on Solar by Googling Solar Oregon. You can also visit this link here, or just follow us on social media and keep checking Eventbrite. If you Google Eventbrite Solar Oregon, it's the first hit on Google, and on Eventbrite you get to see all the upcoming webinars. We encourage you to use the Q&A and chat features to ask questions. And a little bit about myself. During my 9 to 5, Monday through Friday day job, I work at Pacific Northwest National Laboratory as a building energy efficiency research engineer. So I sort of get to work in the field that I am very passionate in. I also post a lot on LinkedIn, and so you can follow me on LinkedIn. Um, a little bit about me. A little disclaimer. The presentation does not necessarily represent the position of Pacific Northwest National Laboratory, U.S. Department of Energy, or necessarily Solar Oregon. Best efforts have been made to convey facts and information accurately. However, you're encouraged to do your own research and calculations before making investment decisions. So a little bit about this webinar. We're going to talk about what happens if you don't sequence work correctly when it comes to weatherization. And then we're going to talk about the right way to weatherize your home. And then we're going to get to some conclusions. So the consequences of improper sequencing is that you get some very unhappy trades. That's one thing. No trade really likes enjoying swimming through and wading through insulation, whether that be your solar installer, your HVAC contractor, or your electrician, or your plumber. Um, and in addition to that, there's also an issue with moisture. In a subsequent slide, we're going to talk about how insulation can actually accelerate or exacerbate moisture problems. You need to solve your moisture problems first before you consider air sealing and insulating your home. Um, and then additionally to that is that if you just go straight to weatherizing, you may have a home that has existing ducts that are not in great condition, um, range hoods or bath fans that are not working very well. And if you don't upgrade those ahead of time, you may be, again, swimming through insulation and damaging air sealing details in order to replace a bath fan that runs through your attic, for example. Same thing with light quality. So if you have a LED light that you spray foam and air seal, but that LED light is producing not exactly the best quality light. Well, now you're sort of stuck with that LED light until you go in swim through insulation and damaged air sealing details to replace that light. So things to think about as a consequence. And so we keep seeing many homes that are not that old, but they have insulation in the walls because they're not that old. They're built during the era when builders knew that, homes need to be insulated. But we have this era of between, I don't know, about the 1970s and on, sort of even up to present day, where homes have insulation because it's required and a good idea, but the waterproofing and flashing details are not done really well. And that is a major problem because homes that were, 100 years old back then, like people didn't really understand flashing details and using caulking and all these other modern waterproofing products we have. But those homes, the wood, if you take apart a 100-year-old home, that wood looks pristine. So what's going on, with homes that have insulation? And what's going on is that the insulation is reducing the amount of heat that is spilling into the attic or spilling through the wall. And so you're reducing the drying force, the drying energy that keeps that wood in good condition. And so now if you insulate a home, but you don't really double down or really get that waterproofing correct, then you're going to end up with wood that's rotten because of moisture and water damage. And so if you have a 100-year-old home and you don't make your the flashing details up to modern standards, and then you go and drill and fill those walls with insulation, you will very likely have moisture issues. And so it's really important to address that flashing detail first and get that flashing detail inspected. And a particularly important location is like corners of buildings because that's a high exposure area and around windows, especially windows that have been retrofitted or replaced because um, the window replacement industry is very interesting. They give you a lifetime warranty frequently to for against a window leakage, leaking water. Well, that's just on the window itself. Where the window transitions into the wall, if it leaks there, eh, that's not part of the warranty. In fact, that if that leaks and damages your wall and causes $25,000 of water damage to your wall, well, now you're on your own. So you have to really be careful about replacement windows because those can cause tens of thousands of dollars of damage to your wall if it's not done correctly. And the other thing is, if you do weatherization and then get other trades to come in, um, electrical, plumbing, HVAC. These trades like to drill holes and drill and cut holes, and they're not necessarily very good at filling them back up and air sealing afterwards. You ask some of these trades whether they even carry spray foam in their truck, and some of them don't. So, like, here's some examples of a home that I looked at. New construction, 2024 new construction. It had three ductless heat pumps and it advertised as a very energy efficient home. Zero of the three ductless heat pumps were air sealed, so they had huge holes behind each one. So now you have a very efficient ductless heat pump, but it's leaking massive amounts of its conditioned air into the wall and then outside. So this home effectively is not very energy efficient, even though it has very energy efficient HVAC equipment. The one of the ductless heat pumps even had a additional hole in the middle because the installer thought that that's where they wanted to run their line set and electrical connections, and then they found out, oh well, I actually need to move over like a foot and a half. So then he then left that hole there, hidden behind the ductless heat pump, and so we found it with a blower door. Here are some other examples of HVAC that I've looked at in slightly older homes, and again, very very shocking to see such large holes and gaps and between conditioned space and unconditioned space. So it really leads me to wonder, okay, well, when you get your HVAC equipment upgraded, are you really saving energy if you're losing quite a high percentage of it through the new holes that were put into the walls and ceiling that are not sealed. So this is why I'm going to encourage anyone who does want to weatherize their home to actually get HVAC done first, and then have a actual air sealing installation crew come back. But even air sealing and installation crews, they have hard time sealing holes that they can't access, like behind a ductless heat pump. Like you're not going to expect an insulator to take apart a ductless heat pump off a wall to insulate that hole that's behind it. It's like if it's not accessible, they're not going to do it. So, it also it behooves you as a homeowner to watch your trades and make sure that they're not doing something ridiculous like this. And then insulation companies sometimes will ask, will propose that, if your home has some insulation in an attic, to just add some additional insulation. And sometimes there's even rebates to this method of improving the energy efficiency of a home, is to just add some insulation. And I really encourage homeowners to just not accept this as an idea. And the reason is because adding insulation doesn't improve the air sealing uh, of the home, the air tightness of the home first. And here you can see a home that has two color, very distinct two layers of blown-in insulation. So the home originally only had like 3.5 inches of insulation. So they blew in many more inches to make it, modern insulation R49, for example. But you see on the left-hand picture, like none of those, bird blocks around the perimeter of the home was air sealed at all. And here lies the problem, is that even though it had, 14 inches of insulation in the attic, when you do a thermal imaging scan of the home, you see just this blue, cold air in winter washing the ceiling perimeter around the home. And you're like wondering, well, why is that? Well, it's because This fluffy insulation does not s- keep air from moving through the insulation material. It's fluffy. It's air, permeable to air. And so when wind is blowing through all these gaps where you can see light coming through, it's putting cold air through the insulation, rendering the insulation basically ineffective. And so then you see that in a thermal imaging scan. And so you need to in order to air seal this, you need to remove all the insulation down so that the attic is clean, and then you can go in and air seal. So this is why the just add some insulation is just not a good idea. So to find air leaks, you need to hire a technician who's competent in running a blower door and competent in um using a thermal imaging camera to help you find leaks. And it's really important that these air leaks are documented. So, like, ask your energy efficiency technician to either send you the photos of that they took with their thermal imaging camera, so that down the road, if you're gonna do the air sealing yourself, or you have an installation crew come back and do the air sealing for you, that they know exactly where the leaks are. Because um, I've seen many companies operate where the person who does the thermal imaging scan and blower door is not the same person that is running around with a spray foam gun doing the air sealing. So then if they're not the same person and it's on a different day, how does that information get transferred from one person to another? And sometimes that information doesn't get transferred, which is kind of a failure in process, in my opinion. Um, you can either the best is would be the photos, but if you don't get photos of everything, then walk around with like blue masking tape and put a piece of masking tape at every single location that needs to be looked at in detail. So that would be a good way to do that. And when the blower door is running, thermal imaging cameras is a really good tool to find those leaks. But another kind of good way is to use an additional manometer and to start closing interior doors and checking the pressure difference between that room and like the main hallway of the main body of the main hallway of the uh, house, and then seeing what that pressure differential is. If there's a major leak in that room, you're going to find a pretty significant pressure differential between that room where the door is closed and the main body of the home. And here in this example here, we did that test, and um, there was this one bedroom that was extremely leaky, and it turned out that the patio door was installed, and there was no air sealing around the perimeter of the patio door, which is mind blowing. But anyways, cold air was leaking through the entire perimeter of this patio door, and it's a very significant air leakage. So another thing to get before doing air sealing and insulation is to test ducts and HVAC equipment. Um, the reason why is it makes no sense to make ducts that are leaky more tight if the ducts are not the right size, and if the ducts are extremely dirty from air leakage, like sucking in blown in insulation into the ducts, or just extremely dirty because the ducts are really old and have not been cleaned since the day they were installed, then sealing them up, is that really a good idea? Um, and so there's some things to do to test HVAC equipment. One is we want to see that the amount of airflow to each room is roughly what it should be. Like, okay, if you have this giant room and you have 20 CFM of air going through that supply grill, then that's not even close to being correct. Same thing, we want to know how much leakage there is in ducts that are, especially ducts that are going to outside of conditioned space, because uh, you're literally throwing money out the roof or out of your crawl space if you have duct leakage. Um, so this is really important testing to figure out what sort of duct corrections are needed before like an attic or a crawl space gets insulated and air sealed. And so in this example home, the ducts in the attic is not supply ducts, but just the return duct. And the return duct had duct leakage. And of course, you saw in that earlier photo that this home had in the attic blown in insulation. So it's a return duct, so it's negative pressure. And so it spent, many years sucking in dust from the blown in insulation. And so in the leftmost photo, you see just how coated those ducts were. And so the homeowner made a choice to just have those ducts be replaced. And so you see new ducts be installed. The other thing that was found in this attic is that the ducts were also partially crushed from subsequent trades having to, straddle and acrobat up and around and over the ducts, this return duct, and sometimes unsuccessfully. And so the duct was partially crushed. And so when the duct was replaced, the choice was made to install commercial grade spiral ducts. And so these ducts are much more heavy duty and rigid, so that if a trade in the future had to go in the attic and they bump into this duct or even accidentally lose their balance and sit on it, that it would not necessarily crush. And so the middle and right photo is the duct being installed, and it's gotten a very heavy dose of mastic to seal all the seams, make sure that it's airtight. And then, of course, we don't just do visual inspection of air sealing. We do a duct test to, again, verify that, these ducts are really tight before closing it up. Same thing, bath fans. It makes no sense to air seal a bath fan um, if it's not actually moving air or it's extremely noisy. And so we have a bath fan here that it was found that it didn't move very much air, and the cleaning attempts to try to clean the bath fan didn't really improve the airflow. So then the decision was to replace the bath fan. And one thing that's interesting is when replacing a bath fan, there's bath fans of all different sizes. And so if you don't want to do a significant amount of drywall patching, it behooves you to try to find a bath fan, a replacement bath fan that's the similar size to minimize the amount of drywall patching required. But if you can find ones of the similar size and then still have multiple choices, then obviously pick the most quiet model. And then before you go and air seal the bath fan to the drywall, for example, to test the bath fan once it's all hooked up to make sure it's moving a satisfactory amount of air and that it's sufficiently quiet. And then afterwards, air seal that bath fan so that you're not having a thermal image like the one in the middle of the slide, which shows that when during a blower test, the bath fan was not air sealed, and so it was leaking a ton of air, cold air into the conditioned space. And when it comes to bathrooms, it's not just air leakage. The moisture in the bathroom is also going into the attic and damaging the insulation up there. And then you can also even, if you get enough moisture up there, you can get icicles growing inside an attic in cold areas like Minnesota, but it's a little bit less common in Pacific Northwest area. Maybe in Eastern Oregon, you might have days where you can grow icicles from moisture going into an attic, but not so much in the Willamette Valley. Same thing with range hoods. If you, especially if you have a range hood that goes through an attic, it's really important to test that range hood to make sure that it's moving enough air. And if it's not, then investigate whether the problem is with the range hood or with the range hood ducts. In this case, the problem was with the range hood ducts. Um, I don't know who installed this range hood, but this was the hack job that was discovered in the attic. Um, wrong pipe, wrong termination. Everything's wrong with this range hood, and it's no wonder why this range hood is very noisy and didn't move any air. And so the solution to this was actually to not use the vent termination in the right-hand side of this photo, which is uh, not even the correct type of termination for a range hood, and then to cut a hole in the roof to install a correct termination for a range hood, and then keep that original roof vent for its intended purpose, which is to exhaust hot air out of the roof. But sometimes it's not the ducting, sometimes it's the range hood, and some range hoods just really suck at capturing cooking emissions. And so, if you have a range hood that runs through an attic, especially, if you're going to do attic weatherization, to replace that range hood beforehand, because sometimes the range hood that you want to get that has very good capture efficiency needs a different diameter duct, and so then you're in the attic making, cutting the hole bigger and replacing that ducting to be the correct size. Um, in order to have a very quiet range hood, you generally need a pretty good sized duct, like a 7 or 8 inch duct, in order to have low enough static pressure to allow the range hood to flow air effectively while staying quiet. Um, Here's an example of a range hood that we're testing to make sure that it's capturing even the front burners very effectively. Not all range hoods do this, so you want to test different range hoods, re read reviews online from people who have purchased the range hood, and read the reviews to see whether what they think about the capture efficiency. And then electrical is also another area, especially in older homes. There are often very deficient, and so often wires run through crawl spaces and attics. And so, if you are upgrading electrical systems after you do air sealing and insulation, then the electrician is very likely having to swim through that insulation and damage the air sealing details in order to upgrade the electricals. One of the things to look for is aluminum wiring. Aluminum wiring has a issue where when it heats up, it expands at a different rate than the copper, and so that high rate of expansion will gradually make the connection looser and looser, and so then you then have electrical connection issues. A really good test for electrical is to do a load test. And so there's tools that can do load testing on outlets. And so this load tester, what it does is for a fraction of a second, it puts like a 12 amp load, or for a fraction of a second, it puts a 20 amp load on this receptacle. And then it measures during that fraction of a second when the load goes on, the voltage drop. And if you have a receptacle wire run that's very long, you will end up having a very high voltage drop, and you can end up having appliances that don't work properly, or overheat the wires in the wall if you plug in something that uses a large load, like a space heater, for example. And this is what we found in this home. The right two photos show this circuit map for one circuit. There was like 40 items, receptacles daisy chained onto one circuit. And it's no wonder why at the receptacles near the end of the line that we're getting incredibly high voltage drops. And so before air sealing and insulation of this home, a new electrical wire was run to break up this daisy chain so that the receptacles near the end of the line gets much less voltage drop. Some other things were found, such as like reverse neutral and hot wire runs. That happened to be a dishwasher plug, so it was out of sight and therefore inaccessible and not tested during the home's original electrical inspection many years ago. But we found it by pulling the dishwasher out to air seal around the perimeter of that dishwasher, which is on an exterior wall, and decided to test that receptacle. And lo and behold, it was not wired correctly. Sometimes, if you make enough electrical upgrades, you might need a larger circuit breaker panel in order to accommodate the additional circuits. Um, and sometimes, if you look at a circuit breaker, you might just want to upgrade it just for the additional new safety features that are in a modern panel. So, such as AFCI breakers that may not be available in the uh, old panel. like the old panel cannot accept these new modern breakers. And so the in this example home, the electrical panel was upgraded to have more slots and be able to accept modern safety circuit breakers like AFCI breakers. Some other things to look for when it comes to electrical upgrades is if you have a level two electric vehicle charging equipment and you're using equipment that is plugged in. Uh, Sometimes in homes, the old homes, people just find a unused dryer plug and they plug in that electric vehicle charging equipment to that plug. Well, if that plug is not rated for continuous high amperage draw, it has a high likelihood of melting and causing all sorts of problems. And so you want to upgrade that plug to one that's actually rated for EV charging, just as a plug for that. Not just inspecting electrical, but it's important to inspect plumbing. This home clearly has been insulated already. Well, that insulator did not do a very good job air sealing those penetrations in the crawl space beforehand, as you can see in that middle photo. But in addition to, not having air sealing, there's some questionable plumbing connections that were found. And so those plumbing connections were remade so that they are not at risk of exploding and causing a massive water damage in this home. So it's very good idea to have a plumber inspect the plumber before having a weatherization crew come and do air sealing and insulation. And so once you get this testing, all this test done and inspection by electricians and plumbers, HVAC techs to do the testing and also the people who can do blower doors on your home, then you have this data, then you can start planning, okay, what do you want to do? Because like, for example, if like all the electrical and plumbing upgrades is enough to run out of your budget, then hey, even though you didn't get to air sealing and insulation, at least you've made your home a lot safer electrically and on the water side. So that's a win, in my opinion. Um, it would be a lot. The story will be very different if you had spent that money upgrading electrical stuff and you spent that money weatherizing and then discover that, oh well, your electrical is actually bad and you have to go and swim through insulation and damage air sealing details. So like that's a worse investment in my opinion. So if you have then budget to like do all this like electrical upgrades and the HVAC upgrades, and then now you're ready to do insulation, um, then what do we do? Um, One is to before you even do the stuff before, if you have insulation in your attic, you may want to have somebody vacuum that insulation out so that the wires can be inspected, visually inspected well, that the HVAC can be inspected well. If it's currently like buried or half buried with insulation, your electrician cannot do a very proper inspection of the electrical system in your home if it's buried in insulation. So you want to remove that insulation and then also like I said at the very beginning of the presentation, removing the insulation is important in order to do a proper air sealing. And so in addition to, your mechanical, electrical, plumbing, this whole idea of, oh, well, we can air seal your attic while there's insulation in the attic. It makes no sense because nobody can have X-ray vision and see through the insulation, know exactly where every hole is. So this home had that when the additional, 10 inches insulation were added to the attic, they swam through the first 3.5 inches to try to do some air sealing. And as you can see, there's some blobs of spray foam in like one or two wires, but then they miss like 80% of the other holes and gaps in the attic because they couldn't see them. So this is a really dumb idea to try to um, air seal when there's insulation in an attic. And then also, none of these blobs of insulation spray foam is effective because they were sticking onto a dusty surface, and so they weren't effectively air sealing anything, even though they looked like they had a blob of air sealing foam there. Um, Sadly, there are programs that actually give rebates to insulation crews to add insulation and then do like a sort of hand wavy method of air sealing, which is you and I know it's completely ineffective. So um, there's a lot of lackluster weatherization out there. So you as a homeowner need to be aware of that and make sure that you don't become another home as an example of that. And a good ex thing to ask your insulation and air sealing crew, your weatherization crew, is to kind of vet a good team versus a good company from one that, is going to maybe do lackluster work, is to ask them how are they going to air seal and insulate on top of an exterior wall top plate? That's a very good question to ask because this is a very difficult space to access. There's only like 3 inches of space on top of the top plate, um, and often you need to get a attic ventilation baffle into this space as well. So if they tell you that they are going to spray foam that on top of the area, that's a good answer. If they tell you that they're just going to blow insulation against this area, that's not a good answer. And then when they say that they're going to put foam into this area, you should ask them, well, how are you going to actually reach that area with the foam? Because if they say that they're going to just, you know, magically, get really small and be able to get there, then that's not a very good answer. If they tell you that they're going to use really long spray foam guns in order to reach this area, that's a good answer. So you have to think practically, okay, how is the actual insulation guy going to get to this area to actually apply spray foam? They are going to spray foam it. So spray foam guns are available in different lengths. You go to your local home center, you typically find a spray foam gun that's, about 12 inches long or shorter than that. But they make spray foam guns, as long as 40 inches, and there may be even longer ones out there. So these long spray foam guns are really, really useful for reaching into like the exterior perimeter top plates of your home and getting that good air seal in that very critical location. So another thing that I've discovered is that air sealing, there's different methods of air sealing, and they have different levels of effectiveness. Very common is the type of spray foam that comes out in a line, and people will spray foam and air seal an attic, kind of in that lower left-hand picture. That's a very typical way that it's air sealed. But then if you look very carefully, like you'll find that that line of spray foam doesn't always actually seal anything. As you can see in the very skinny photos that are showing particular spots where it's not air sealing. So I've been testing these wide spray can foams, and here's a photo in the far right, an example of one brand that comes out in purple, but there's many brands and they all come out maybe in different colors. But that's not the point. But the point is that these wide spray can foams, how they work is it's formulated to be a little bit less viscous. So they come out, it can come out in more liquidy form. And they come with tips to that you mount, attach onto the tip of the spray foam gun. And you're able to spray foam like both sides of the top plates at the same time and get about like an inch or two of air sealing foam on top of these areas and then just effectively just completely air seal the entire area so that there's no chance that you're going to end up having these issues of a line of foam that doesn't actually bond to the correct space you want and therefore not being effective. So if you have a company come and do this or you're going to do this yourself, I really encourage you to look at these spray foams that are designed to be sprayed in a wide spray pattern. I spoke a little bit about lights, and if you're going to air seal lights to make sure that they are um, actually lights you like, because um, a lot of these canless recessed lights, especially the early generations ones. They produce light that's not exactly the highest quality light. And if you're going to air seal these lights to the drywall, then, well, if you're going to try to replace them down the road, you're chiseling that spray foam out of the way. So it behooves you to upgrade the light before you spray foam the lights against the drywall from the attic. And these lights, they do leak air. I mean, I've never seen one not leak air. So like you do need to seal them, even though they've got these spring-loaded hinges to try to, so supposedly, press themselves against the drywall to reduce the air leakage. But they're not airtight unless you seal them with spray foam. If you do have a canned recessed light, though, um, I encourage you to not bother to air seal that one. These types of recessed lights from the attic. Instead, use an airtight LED retrofit kit and stick it up from below, and then just caulk the trim around the drywall to the drywall, and then you're going to end up with an airtight assembly that way. If you have a HVAC company come and install any sort of ductless indoor unit that penetrates through a ceiling into unconditioned space, be very mindful. Ask them lots of questions about how they're going to air seal this indoor unit so that you're not creating an air leakage path through the perimeter and interstitial space of this ductless indoor unit. Um, so if a good HVAC company will build a box and then put this ductless indoor unit into that box and then, seal the box closed so that, it's airtight. But the actual piece of equipment itself is not airtight. They are not designed to go into a residential ceiling that goes from conditioned space to unconditioned space. They're designed to go into office buildings that, have drop ceilings, and those drop ceilings are inside conditioned space. So if you're going to use it in a residential space, you kind of have to do some kind of thinking on how to actually do the air sealing part of the equation. If you're going to work with an insulation company to air seal your home, uh, and your goal is to get the home really airtight, you need to think about mechanical ventilation if your home doesn't already have mechanical ventilation. And so, like in this home, an ERV was added because we knew that the home would drop below 5 ACH. In fact, this home is now at 3 ACH. It started at like close to like 9. And so at 3 ACH, you definitely need mechanical ventilation. So this was added before um, air sealing and insulation occurred so that the penetrations into the attic for this mechanical ventilation could be air sealed. And if you're going to install an ERV or an HRV, remember that they need to be balanced, and so check the instructions for commissioning and balancing instructions. Um, and then same thing, before you blow in insulation, which is a very dusty process, make sure that any areas that won't get insulation because it's either too tall and it'll sit above the insulation, or like for example, an attic hatch, like you're obviously not going to blow in insulation on top of an attic hatch, that these areas are insulated in some other methods, such as using rigid foam, to get as good of an R value as possible and try to match the R value of the rest of the attic so that they don't become a thermal superhighway to bypass the insulation that you blow in the flat areas. Sometimes even with a gasket and layers of rigid foam sitting on top of the attic hatch, there's still not enough weight to get that gasket to seal. So you may want to get a latch to help pull that attic hatch tight against the gaskets so that you don't get a thermal image like that upper corner. These gaskets, these what's it called, rolls of um, gasket material, they don't always stick that well to drywall. So, adding some contact cement before sticking the self-adhesive foam really helps keep this stuff in place. Um, before you, when you're done with air sealing, when you think you're done with air sealing, it behooves you to have a second blower door so that you're blower dooring and thermal imaging again to catch any missed air sealing opportunities. Um, as you can see, it's dramatic difference once that return Plenum was air sealed between the left and right thermal image. Before you blow in insulation, make sure that if there's wires that will become buried in insulation, that they're marked so that in the future an electrician knows where to find them. And then if when it comes to blowing in insulation, uh, if you're contracting it out, make sure that you're counting the number of bags of insulation that's going into your attic and make sure that it meets the minimum number of bags of insulation for the area of attic that you have. And these are tables that are either downloadable as a PDF or they're also even printed on the side of the bag. Many insulation companies, I'm not saying all of them, but a non-trivial number of them will try to, fluff up the insulation and not blow in as many bags because it's fast. But you do need to, once the insulation settles, in order to get an effective settled R value that you paid for, you need to blow in at least the minimum number of bags according to those tables. So we've just kind of focused on the attic, but that's not where all the air leakages are. Windows and doors are another area where there's a lot of air leakage, as you can see in that thermal image, wispy lines all around the perimeter. And it's because oftentimes window and door people also don't carry spray foam and they don't seem to have a concept for air leakage either. And so this home is the windows and doors were finished already, so the trim had to come back out. So all the trim was pulled so that it could be spray foamed and then the trim reinstalled. And then with windows and doors, it's a good idea to use tape in addition to spray foam because when you slam the door, slam the windows and stuff, the spray foam can actually down the road crack, and then you could get a little bit of air leakage there. So the tape is like a boot and suspenders approach to air sealing, so that you get long-term, long-lasting air sealing before reinstalling the trim. Same thing. Like here's pictures of the door, the windows. The trim is getting pulled and the backer rod getting shoved in because, as you can see, there is no spray foam done around these windows, and so that's where they were leaking air. Baseboards is another area that gets tons of air leakage, and this is an area that, like, I've wondered how is it possible with platform framing and exterior sheathing that you end up with so much air leakage around baseboards, and and then of course I'll show you pictures of that reason why later. But also, if it's leaking around baseboards that you can see easily, it may be very likely also leaking air around baseboards you cannot see, such as that subfloor to bottom plate connection behind base cabinets. And a way to reach this is that you can drill holes into the toe kick and use that 40-inch long spray foam gun to spray foam the back area and to just put a new decorative piece of wood to cover up those holes around the toe kick. But anyways, I've kind of learned why subfloors are so leaky to the bottom plates of the wall. It's because in here in the Pacific Northwest, it rains a lot, and we keep building homes even when it's raining. So the subfloor will get really wet during construction, and the OSB subfloor will swell, and then it causes uneven ness around the between the subfloor and the bottom plates. And then the exterior sheathing that's supposed to, go around that area is not always that continuous. So there you go. This is why the subfloor of the bottom plate is so leaky, even if it's a not slab on grade construction, but like a platform bit crawl space construction. This is why. Um, Again, around electrical boxes, even ones on the wall, it could be an interior wall and it'll still be really leaky. It's because electricians, they don't always carry spray foam and they don't always drill holes that are that tight against even the box. And so you can see in the middle photo big gaps between the box and the drywall. So the solution is to remove the light fixture, do some air sealing, and then put the light fixture back. Heat pump water heater in this case, it's funny that there's a really efficient heat pump water heater, but the hot water pipe is not insulated, and then the holes for the drywall between the garage and the house was not air sealed. So, there's significant additional energy efficiency to be gained once the hot water pipe was insulated and the penetration sealed. Um, so here's a little short list of this wide spray foam. There are now just tons of white labeled brands. I imagine that there's only like maybe two or three actual factories that make these wide spray formulated spray foams, but there's like maybe a dozen or even 2 dozen white label brands. So they should be all very similar, but read the reviews before buying them. And then if they're not even very clearly labeled whether they're the wide spray type foam or not, look in the pictures of that listing for a listing that shows that they come with tips, these tips that go on the end of a spray foam gun. And these are the type of foams that will let you spray foam and air seal much faster and more effectively. Most of these listings will try to sell you these foams as like your primary way to air seal, not only just air seal, but insulate your walls and insulate your attic and stuff. Ignore those uh, ideas, okay? Just delete them out of your head because you should not use can foam to insulate to like, R21 or R49. Um, with can spray foam. Like you would go through so many cans, and the evenness of that foam is not going to be good if you need to spray it that thick. This type of spray foam is really designed, uh, should be designed, and it really should be only used for air sealing, where you spray like an inch or 2 inch thick air, and like little areas, like for example, that area on top of the top plate around the perimeter of your house. This is a very good use of that spray foam, but you want to use, if you're going to spray foam huge areas, you want to hire a spray foam contractor that has a truck to spray foam. Um, or better yet, just use blown insulation for, actual insulation because, that stuff is a lot more environmental. So, anyways, in conclusion, it's really not a good idea to jump straight into weatherizing. You could end up with moisture issues, and then again, like you're very likely in an old home going to need some HVAC work, electrical work, plumbing work, and if this work happens after your air sealing and insulation is done, then all these trades are just having to wade through the insulation, and they don't like that, and their chance of injury is high, and they're going to damage the insulation, they're going to damage the air sealing, and so it behooves you to get all this, stuff. And in the sequence of construction, new construction, you'll see that all the electrical, plumbing, HVAC stuff gets done first before the air sealing and insulation crew comes. So why should it be any different in retrofit? Um, so, you as a homeowner, you're going to be uh, sort of coordinating this to make sure that the sequence of work is done correctly. So that's kind of your job, and your job is also to make sure that the work is done to a high quality manner. And I've shown you pictures of examples of when things are not done to a high quality. So like you need to keep an eye on the work that you're paying good money for. And then when your insulation is removed so that your electrical and plumbing or HVAC can be upgraded, you're likely going to have days, if not weeks, without insulation. So be prepared to have a space heater, little space heaters to keep, your house sort of warm during those days. And you're going to be during those days, you're going to be uncomfortable before you get more comfortable. So like, just be aware that when you're upgrading a home, that whole process of upgrade, there will be days and weeks when you'll be uncomfortable. Same thing with if you're going to do ducts and HVAC upgrades, I've never seen anybody do ducts and HVAC upgrade done in one day. It takes multiple days to do that work, minimum. So you're going to have days when you don't have central heat. So you're going to need a space heater to get by those days. But it's necessary to do it right. So you just have to be prepared for that. And so I want to do a plug for the next Green Energy series, which is on February 7th at 10 a.m. Saturday. And that topic is going to be about buying high performance windows from Europe. And the reason why I want to do this topic is because you can get really high performance windows for fantastic prices. And so, mark your calendars for this Green Energy series. I think it's going to be great. So now I'm going to jump into some questions. I want to see what kind of questions there are. Okay. There's a question about two-stage application. That's probably about the foam. No, the foam in this case is a one-part foam that comes out of a can. Another question is how to possibly ensure proper installation of weatherization measures, including air sealing and installation contractors. There are so many reasons to take shortcuts and compromise quality of the job. Seems like you almost need two contracts to ensure the first contractor is properly installing. Yeah, that's not a bad way to do it, is to have a insulation contractor that does both just the air sealing and insulation, and then you have a energy audit type company do the blower door and thermal imaging, and that they work together. Um, I strongly recommend that, if you're a homeowner, that you get the two contractors to, share information so that if you have an energy audit company, that they are sending photos and a punch list of places to air seal, for example, to that air sealing crew so that it gets to that air sealing crew, and that on the day that they show up, that they have that printed sheet in their hands, and that either the energy audit person is there also, or at least the homeowner's there with that punch list, and like checking off that things are being air sealed. So that's you have to figure out how to coordinate that. But I'm just if you don't coordinate it, it just doesn't happen, and then you don't get very good results. Uh, Now the question is, can you speak to sealing off crawl space vents and treating crawl space semi-condition with vapor barrier and air sealing? Very, very good idea to do crawl space encapsulation, but the details on how to do that is maybe a topic for another Green Area series. But it's expensive, but the results are very good. Is it always necessary in the Pacific Northwest? Not always, but like, we're in a very, very unique climate situation where like a vented crawl space actually works. Many other places, it just doesn't work at all. So then like for example, in Florida, if you have a vented crawl space, it's complete disaster. In North Carolina, complete disaster. And so like, you know, Portland, Seattle is like marginal. Like it works most of the time, but then, if you have anything slightly off, you could tip that scale to being a disaster also. So which is why like, you know, crawl space encapsulation is actually still a good idea in the Pacific Northwest. Um, Another question is two-stage application, photos show orange foam, then cover purple foam. I see, I see. Okay, so the story with that is I started using like the type of foam that is not wide spray because I just go to like Home Depot, Lowe's, and buy that foam that's available off the shelf. And then I discovered that that foam doesn't work very well because I then did a blower door test uh, and thermal image, and then discovered, wow, even though I air sealed, it's still leaking air like crazy. And then I went to look carefully to see why is it still leaking, and I found areas where it's not actually effective air sealing. So then I found this wide spray type can foam and use that instead. And if I could go back in time on these photos and like start with the wide spray foam, I would totally do that. But hey, you learn what works and what doesn't by trial and error, or just, you know, taking the information that is available and testing it. And then if it doesn't work, then you find a better product and a better method and a better solution. And then you then tell the rest of the world that you know what you've discovered as the better way to do it. Okay, so, and then that's the questions. I want to see if there's in the chat, there's anything more. Let's see, how do, come on. Let's see. Turn off screen share. Now I can see the chat. Mm, Nothing in the chat. And okay, great. All right. Well, I've gone through all the questions and in the chat. If feel free to visit Solar Oregon's websites. There's a email address there. It's info@solaroregon.org. It's a .org. If you have any other questions, you want to email Solar Oregon, and they'll be able to get those questions over to me, and I can help answer them via email. If nothing else, I hope you guys all have a great rest of your Saturday, and look forward to seeing you at the next Green Area series, which is February 7th, on importing high performance windows from Europe. I've done it. I'm really, really happy with those windows. And yeah, I hope to be able to tell you more about that process. And with that, we're going to close out this Green Area series and have a great rest of your day.